triangles are basically coming from the first two perfect shapes, which is the equilateral triangle. Okay, so we're looking at half of the equilateral triangle, and we have the square, okay, and we're looking at half of that square. And because of symmetry, we don't really need to work this out. We don't need a calculator for this. We can just use the symmetry of these two shapes to be able to get the different parts of it. So this is a 30-60 triangle, and we know that if we let the side lengths all be 2, 2, 2, this is going to be 2, 1, and then using Pythagoras we can work out that side as root 3. Same as this one here. If this is a square, we can just say that that is 1 and 1, and the length of the diagonal is just going to be 1 squared plus 1 squared, and square root, we get square root 2. Okay, so those are two special triangles, and it's important to memorize and be familiar with these ratios. So when these ratios show up, that we recognize them as special angles. So when we talk about sine of pi over 6, we know it's going to be the opposite side here over the hypotenuse. The cosine is going to be that length, the longer length over the hypotenuse. And the tangent will be the slope. So it's going to be slope is 1 over root 3. Okay, so in standard position, it's a lot easier to see the slope, but in the triangle, you can still see that is 1 over root 3 is my ratio. For pi over 3, the 60-degree angle, the sine is going to be the opposite. So it's going to be root 3 over 2. So instead of the adjacent side, that's now the opposite side of that angle. So these two actually match. And then the sine of that, so cosine of pi over 3 is going to be the same as the sine of pi over 6. And then the slope is just going to be, instead of opposite over adjacent, it's going to be this opposite over this adjacent. So it's going to be root 3 over 1, or just root 3. And then looking at the other triangle here, the 45-degree triangle, sine will be 1 over root 2. Now some people like to write it as, I shouldn't write it approximately, some people write it as root 2 over 2, so it's good to recognize both of these. This one seems a bit easier to use, I think, okay, because we can actually see it, right? 1 over root 2. The cosine is going to be the same, 1 over root 2, and the slope is going to be 1. Okay, so that tan slope is really easy to work out. And we should be able to now go from angle to ratio and ratio to angle without a calculator, because we should be familiar with these shapes. So for example here, the pi over 3 indicates as a special triangle. We know that it's similar to this 1 to root 3 triangle. And we can just use these ratios then to work it out. Now we could use similarity to do this. Okay, and we can use the ratios between the two shapes. I can say that this side relates to that side, this side relates to this side. But we're going to use trig, which is ratios within the triangle. So I'm going to solve for x in this way. I'm going to say the opposite over the hypotenuse is my sine of pi over 3. And I'm going to say that that's going to be the sine of pi over 3 is going to be root 3 over 2. Well, if I have those both equal to sine pi over 3, okay, although they're different size triangles, I can make this equivalence and solve for x. Okay, and here I've used trig to solve for this. Okay, so, and we would have gotten the same result if we did root 3x to root 3, 5 to 2, and then solved, we still would have gotten 5 over 2 root 3 as the same answer. But here in the red, we've used the trig ratio to do this. And we're going to do the same for the y. We're going to use the trig ratio. So we're going to use adjacent over hypotenuse. Okay, so that's cosine of pi over 3. And then that's equivalent to this other triangle of adjacent over hypotenuse, or 1 over 2. And then using this ratio, we'll solve for y. Y is equal to 5 over 2, or 2.5. So same thing here. We can just use our ratios. And again, we want to use this special angle trig ratio, so the ratios within the triangle. So inside this triangle, we're going to come up with ratios. You're being asked to solve for a, so I want to first of all solve for this length x. That is the opposite of this 60-degree angle, or pi over 6. So I'm going to say sine of pi over 3. That ratio is equal to x over 5. Okay, and we know that the sine ratio, if this was a special angle, and if I need to draw it, that's fine. Okay, the sine ratio, so long side, that's the long side over the hypotenuse. So that's going to be long side over hypotenuse. And then I can solve for x. Okay, so it's going to be 5 root 3 over 2. So I'm still being asked to solve for a. Now I could technically use Pythagoras here, but I'm going to do it like this. I'm going to use my 45-degree angle, pi over 4. And I'm going to say that the sine of pi over 4 is equal to this side compared to this side. So a compared to x, which is 5 root 3 over 2. And that ratio is going to be equal to, again, if I need to draw my picture as a reference, opposite over hypotenuse, it's going to be 1 over root 2. Okay, so then what I can do then is I can then use this equivalency to solve for the length of a. So the a works out to be, that's going to be 5 root 3 in the numerator, and then the 2 ends up in the denominator, 2 root 2. Okay, so there's my length a. Okay, and I use my trig ratios to work this out. You don't have to do this, but we want to keep exact values. So if you're going to use Pythagoras, you need to keep everything in exact values to do that. But the trig ratios, we want to get familiar with them, and as we get more familiar with them, they should become much easier to use. So here, same thing, we're given a length. This length is 12.6, and we want to figure out the length of the different cables. So that's a height of 12.6, and that's also a height of 12.6. Okay, this is symmetrical, so we'll just need to solve for one side. So let's solve for this cable first. Okay, so we know that this is a long side of that triangle, so that's going to be the root 3 side to 2. So we're going to say that the sine of pi over 3 is going to give me the root 3 over 2 in my special triangle. In this diagram, it's going to be 12.6 over the hypotenuse, which is unknown. We'll call that x. And then I just cross multiply, solve for x. So I end up with x is equal to 25.2 over root 3. Okay, so there's my x value. I'm going to do the same for y, which I'm going to call this line here. We'll call that y, and we'll use the opposite hypotenuse. So we're going to use sine again. This time we're going to use pi over 4 angle, opposite over hypotenuse in the 45-degree triangle is going to be 1 over root 2. And then we're going to write this as 12.6 opposite side over a hypotenuse side. And then using this trig ratio, we solve. Okay, we're going to get y equals 12.6 times root 2. And that would be my length for the cable y. Okay, so this is supposed to be a bridge. I don't know if I can draw that in very well. This is the road bed here. Okay, you can have some cars driving on here like this. Oops, that's not a very nice car. Okay, and then there you go, there's my bridge.